let's look at this important question under density and upthrust. Now, many students usually find questions like this confusing, but I'm going to make it simple for you to understand. An object of volume 400 centimeter cube and density 2.5 gram per centimeter cube is suspended from a spring balance with half its volume immersed in water. Determine the reading of the balance. And we are given the density of water as 1 gram per centimeter cube. Now, for us to solve this, I would like us to first of all calculate the mass of the object. Don't forget, from the formula for density, we know density as mass. Density, now let me use the symbol. Density is equal to mass over volume. Mass over volume. And we know the volume as 400 centimeter cube. And we know the density as 2.5 gram per centimeter cube. So now let's substitute those values so that we can find the mass of the object in air. That is the original mass of the object. So the density is 2.5 and is equal to the mass that we're looking for, all divided by the volume of the object is 400 centimeter cube. So all divided by 400. 400. From there, if we cross multiply, we are going to get the mass now. When we cross multiply, this is like 2.5 over 1. So m multiplied by 1 is the mass. And that will be equal to 2.5 multiplied by 400. 2.5 multiplied by 400. And that will give us the mass of the object as 1,000 gram. So 2.5 times 400 will give us 1,000 gram. So that is the mass of the object. Now, we are told that when the object is immersed in water, we are told that half of its volume is actually immersed. That is, half its volume is immersed in water. So volume in water now, or let me say volume immersed. So the volume immersed, let me use V substitute I, is equal to half of the original volume. That means half multiplied by the original volume is 400. You can see it from here, 400. So multiply by 400. And that will give us the volume immersed as 2. So half multiplied by 400 is 200 centimeter cube. So this is the volume of the object inside the water. Now, to the important formula. Please don't forget this formula I want to write for you now. It is very, very important under density and upthrust. That the density of a liquid when an object is immersed in the liquid is equal to the upthrust experienced by the object. Now, the upthrust is loss in weight. Don't forget, this upthrust means the loss in weight of the object. So the upthrust divided by the volume that is immersed in the liquid. Don't forget this formula. This is one of the most important formula under density and upthrust. In fact, I can call it the most important formula under density and upthrust. Don't forget this. The density of a liquid is equal to the upthrust that the object experienced. That is, the upthrust means the loss in weight that the object experienced. That is, that upthrust should be in gram first. The upthrust should be in gram, all divided by the volume of the object immersed. I'm taking my time to explain this because if you can understand this formula, how to apply it, you will not have problem in questions like this. So let's substitute values. The density of the liquid is the water now because it is immersed in water. So the density of the liquid is 1 gram per centimeter cube. So density of the liquid is 1. And it's equal to the upthrust. That is what we want to calculate now. Upthrust. All divided by the volume immersed. Don't forget, the volume immersed is what we just calculated now as 200, half of the original volume. So the volume immersed is 200. So by the time I cross multiply, I'm going to get, this is like 1 over 1. U multiplied by 1 is U, that is the upthrust, is equal to 200 multiplied by 1 is 200. So the upthrust is 200 gram. So that is the upthrust now. Now, after obtaining the upthrust, we are to find the reading of the spring balance when it is immersed in the water. Don't forget, that is what the question asks us to calculate. Determine the reading of the balance. So that is what we want to determine now. So let me write the formula that we need finally to do that. So don't forget, the weight of an object in a liquid, when an object, a solid, is immersed in liquid. So the weight of the object in the liquid is equal to the weight of the object in air minus the upthrust. Don't forget this as well. The weight of an object in a liquid is equal to the weight of the object in air minus the upthrust. Don't forget, this upthrust means the loss in weight. So when you subtract this loss in weight from the original weight of the object in air, it will now give you the weight of the object inside the liquid, because inside the liquid it has lost some weight because of the upthrust on it. So from there, I can now move on and say weight in air, which is 1,000. Don't forget, we have calculated that at the beginning, that the weight, which is now mass, because we are dealing with mass here. So I'm trying to use formula for, I'm trying to use the word weight, but actually what we are dealing with in this question is mass. So we'll be using mass. So that is 1,000. That is the mass in air, or the weight in air now, 1,000 gram. So that will be in air 1,000 minus the upthrust, which is what we obtain as 200. So the upthrust is 200. So finally, the reading, or the weight, don't forget, the weight of the object in the liquid is equal to the reading of the balance, because that is what it weighs inside liquid. So that will be the reading of the balance. And that will be equal to 1,000 minus 200 is 800. And this is the final answer. Hope you enjoyed this video. Please don't forget to like, share, and join for more videos like this. Thank you for watching.